Abhigyan, the whiteboard is visible or not?
Visible, sir.
Okay. So let us start. This is computer networks, and let me tell you that apart from theory, this subject would be more interesting when you follow the lab part. And lab should be conducted on Friday. Unfortunately, again, it is going to be online, but I'll try my level best to impart whatever I can and whatever best in this mode can be done. Anyway, so let's begin with the things. Uh, Anybody can tell me what they know about computer network, suppose. If I start from you guys, what is computer networks for you? Abhigyan, anybody can tell.
Mainly, sir, what how this client and server request will handle. Study about.
Uh, uh, in a sense, you are right, but it is more technical answer. So if you if we see computer network from nut and bolts view, what you are going to see, you are going to see some end devices which consist your mobile phones, laptops, tablets. So and then there come your servers also, web servers, file servers, YouTube servers, video servers, and all. So the first thing is end devices which are connected to each other, and that's how the things are going to be done when a device is connected to another device. Now, it's not only about connecting end devices. Now, what is actually happening when we say computer network is, okay, machines are connected. Machine 1 and machine 2 are somehow they want to get connected. But more than that, what is going to happen? There is an application here which wants to get connected to the application running on another machine. So, in a sense, it's like applications talking to each other when we talk about interconnecting the machines. It is as simple as that. When you might have used this ping command on Linux. So you use ping and write down the IP address, and you want to check whether that particular IP address is live or not, is active or not, and then you get response like reply from this. So what is going to happen? So there is a ping application which is actually trying to contact the ping application running on the another machine. And then they exchange messages as you have suggested, Abhigyan, that okay, so one fellow must be a ping client, another fellow must be a ping server. So this client must be contacting the ping server, and so on and so forth. In this way, are they are contacting each other. So from a net and bolts view, what you will see, if I have a bird's eye view and I ask you to visualize the internet, or see any campus network, what you'll find end devices, and then you find interconnection links. So this interconnection link can be wired or wireless. So when we talk about wired, it can be a copper or optical fiber. when we say wireless, then you know that we started with 2G, 3G, sorry, 3G, 4G. So this is GSM networks. Now we are moving towards 5G. Then you know this 802.11 wireless LAN standard. So wireless links means you use radio connectivity. So from a nut and bolt point of view, you may find in a network that there are end devices and then interconnection links. One more thing is there must be some networking devices. Networking devices like switches, routers, these names you have heard. So what they do, they actually get your data and then transfer your data further in the network. So if I now draw a small computer network with an abstraction, so abstraction for a computer network in data structure would be a graph. So when we want to represent a network, we represent it by graph. So where we say that these are the devices which help in transfer data from one place to another. So these are networking devices which are routing your data from one place to another place. And with this network, the end devices, host 1, host 2, host 3, and these hosts can be client or server. So these hosts are connected. So when you transfer data, so the data will go from host 1 to a nearby networking device, which is interconnected with another networking device. So hop by hop, your data is going to be transferred, and then it will go to some destination host. So in this way, network can be represented using a graph data structure, where when we say, so there is a popular terminology, the core of network is made up of networking devices, which are your switches and routers, which help forward your data, and then the core of network is connected to edge of the network, and edge of the network is what is made up of your end devices, client server, mobile phones, laptops, web servers, and all. Now this is what. Now then if we talk about what Abhigyan was initially suggesting, that from services point of view, what are the services network is going to provide? So as you know that right now everything is kind of client and server. So you want to open a website, so your browser is acting as a client and some web server is acting as a server. So that web server can be a video server like YouTube, it can be a news server like any news channel, and something like that. So finally, the client is connected to server, client requests, and server replies. It's a kind of request reply paradigm which is working. There can be many applications. We have email, instant messaging, video conferencing, the way we are doing right now, audio conferencing, fine. Normal internet browsing. So all these applications are provided. And these applications are providing you services. So if you visualize carefully, my laptop right now is working as a video conferencing device. The next moment it can also work as a web surfing device. Next moment it can work as a video on demand client where I can watch movie by connecting it to Netflix. So from services point of view, it's a client server kind of thing. Now, how it all is started actually. This is what is a interesting story, but I'll make it very short. Now, before internet, the biggest network all over the world was what? Yes, anybody? Before internet, what was the biggest network? Yes, anybody can tell.
Also, maybe telephone lines.
Yeah, it was a telephone network, and before a telephone network, it was electrical network. Got my point? So biggest network before was telephone network. Now, if you see the telephone network, it is also kind of a graph where you have local exchanges, a small telephone switch. I'm talking about plain old telephone system. Fine. I'm not plain old landline I'm talking about. I'm not talking about nowadays. So there's a local exchange which may be there somewhere in your colony. It is known as PBE PBX. Fine. Where your telephone wires which are coming from different homes are connected. And now these small PBX boxes are connected to some bigger switch, and then they are connected to telephone exchange of a city. So it is again a network of end system which are your landline telephones, then your networking devices like these EPBX and telephone exchanges. Now, if I draw a telephone network in abstract manner, it will also look like the same, the way we have drawn our normal computer network. What is that? These are the telephone switches. Fine. And then there are end devices. Your telephone 1, 2, 3, and so on. Now, what was happening in telephone, and that's what you need to understand. So this is the important concept. In telephone network, what was happening? Circuit switching was happening. Now, when you punch a number to and you want to ring to any destination telephone, and what do? You punch a number. So if we go like 50, 60 years back, uh, maybe 50 years back. So when you want to call from Lucknow to say Delhi, so there used to be manually operated switches. If you have watched some old movies, we used to book a trunk call. So it was a trunk call. So you book a trunk call, and then after some time you'll get a ring back on your telephone that your call is booked and now you can call. So what was happening, if you are trying to call to any destination telephone, a path is formed, and you know in a graph from source to destination there can be many paths. So what these manual operators used to form a path between source and destination. So before any data can be transferred, a circuit is created through the telephone network between source and destination. So this is circuit switching. And until and unless the path is formed, you cannot transfer any data. That is happening in nowadays also. When you punch a number and try to call somebody, first of all you have to hear the ringtone. Means that tells you that a path is being formed between source and destination. So circuit is formed going through several switches for you. And then when somebody picks up the phone, and then you can transfer data through this path. This is circuit switching. Now in this circuit switching, many a time you might have heard this familiar voice that all lines to this route are busy, और इस रूट की सभी लाइनें व्यस्त हैं, something like that. So that's what is, and nowadays these are electronic switches. These are not manual anymore. So they try to form path between them, among them, up to the destination, and then your call can be set up, and then first of all the call setup phase is there, and then you can transfer the data. Now in comparison to telephone network circuit switching, what we use in our network, our computer network or internet, the concept is packet switching. Now what is packet switching? That again these network switches are there which are interconnected through communication lines, transmission lines. So between source and destination, again there are devices. So again there can be many paths from source to destination. There can be many possible routes from source to destination. But what is contrary to circuit switching, what is happening here? No call setup phase is there. Means circuit is not going to be formed between source and destination before any data can be transferred. So your whole message, whatever you want to transfer an image or a voice or video, whatever, that is considered as a stream of bits. So your whole message, be it any whole data, be it image data, video data, audio data, whatever, finally they are digital bits. So they would be packed in some chunks. And in our computer network, we call these chunks as packets. So your whole message would be converted, divided into smaller packets. And now, without setting up any path, you transfer one packet, the device will see your packet, and based on the current situation will forward it to the next hop. It may forward it to this hop or this hop. depending upon the current situation. Whether this path is okay, this particular hop is okay, or this hop is okay, which one is better, depending upon that, we'll take decision packet per packet basis. And that's why this particular concept is known as packet switching. So now these packets, one by one, hop by hop, will transfer between source and destination. And sometimes we also say these networking devices as store and forward devices. They store the packet, check the packet, check for the destination address or whatever. We'll come to these issues later on. And then take some decision, do some processing, take some decision, and then forward the packet. Next device again will store the packet, inquire the packet, take some decision, and then forward the packet. So these devices are also known as store and forward devices. Fine. So now you get to know the difference between circuit switching and packet switching. And I'll come back to this story again, that how this initially telephone network was slowly and gradually, miss, if you see, initially telephone network was utilized to create internet, means a network which was there for voice traffic was utilized to create a network for data traffic. Fine. How many of you have seen in your houses maybe 20 year back, 15-year back, those modems which used to connect your telephone to your computer? How many of you have seen? Abigail?
Yes, sir.
Have you seen this?
Yes, sir.
So your telephone line, telephone cable is connected to a modem, and then you connect that modem to your computer, and then there is a very interesting kind of sound they used to make. Fine.
Yes.
While connecting, and then finally you get connected to internet. Remember?
Yes, sir.
So, so initially that was how we used to get connected to internet. Means in the core the telephone network was there, and telephone network was actually when we used to convert what is modem, modular, demodulator, modulator, demodulator. So we'll come back to this issue. These are data communication things. So you have to convert your digital data into some sort of analog data which can be transferred uh, through the telephone network. Whatever gap is there between the voice traffic, and you can utilize the same channel for your data traffic on the telephone network. So the network which was there for voice traffic was getting utilized to transfer your data. Internet uh, used to run over telephone network. Fine. And now what is happening? Your telephone network actually is running over internet. Yes or no? So we are now using voice over IP. So means your voice traffic is running using internet. This is how the technology has evolved. Can you visualize this, class? Abigail?
Yes, sir.
Right now what we are doing, I'm not connected to telephone, no? I'm connected to internet, and my voice is going through the internet, and your voice is coming through the internet as if it's a data packet. Yes or no?
Yes, sir.
So that's how the technology has evolved, and we'll come back to this later on when we discuss various issues involving computer networks. So that was a difference between circuit switching and packet switching, and how these things have evolved. The next is most important, and that is going to be the last topic of today's lecture. I'm not going to teach you much today, it's the first class. Uh, Next is, you keep on hearing this term, the protocol. Fine. And network protocol. Now, what is protocol? So right now there is a protocol between you guys and me. The protocol is what? That I would keep on teaching. If anybody wants to ask any question, may raise hand, and then I'll get interrupted. I'll give chance to that person. So there is a rule which is happening between me and you, because we people are actually in communication. We people are actually exchanging data. So there are certain another rules that I would not speak in Chinese. I would use English 90% of the time, maybe Hindi sometime. I will use a language which is known to you guys. You all will not speak at the same time. I will speak, and so a protocol is happening. Similarly, network protocol also. So there are rules. So rules means there would be a syntax, and then there would be semantics. Syntax means what is going to be the format of the message. Like you have many types of files in your computer. Some are video files, some are audio files, some are doc files, some are PDF file. So every file is having a header which tells what to do with this data which is after header. So PDF file would be having a header which actually tells the PDF reader what to do with this data. So header gives you how to interpret this data. Means header gives you the way to understand the semantics of the data. But on which byte position, on next byte, whether it is ASCII or extended ASCII, every character takes 9 bits or 8 bits, or how or which type of encoding is used, that comes in syntax. Similarly, in network protocol also there are rules, and then the message format. A message can have many fields, how to interpret those fields, and what is the meaning of those fields. The decision and the structure of all these things is a protocol. So what are the various methods of a protocol? What is the format of request? What is the format of reply? What is the format of reject? What is the format to tell whether you are busy or not? So all these constitute a protocol. Rules, syntax, semantics. Now another important stuff is, and now if anybody is sleeping, please wake up. Another important stuff is abstraction and encapsulation. These two terms you have seen in which subject? Yes, Aman Singh. Abstraction and encapsulation. These two terms you have heard in which subject?
Sir, in object-oriented programming.
In object-oriented programming. So what's the goal of object-oriented programming? What is the difference between a procedural language like C and an object-oriented language like Java or C++?
Sir, everything will be in the form of objects and classes.
No? Anybody else? Abhigyan? Karimullah is there?
Yes, sir.
Yes. You can add something to what Aman has suggested?
Yes, sir. In object and they are independent on each other. And in procedure, there are only abstract class which are predefined.
No, the biggest functionality which object-oriented language provide is modularity. You can develop a system in modules, and these modules can be developed independently. So and that's how you define there is a base class and then subclasses and different. So any system we can divide, and divide. The major goal of object-oriented programming is that only. When you talk about object-oriented design, so you take a system, take any big system which you want to say automate or do any you want to design a system, computer system. So you think monolithically that okay, I want to design this whole system. But then when you observe it, the working of the system, that oh, this is the possible working of system is going to be. So you can think of some independent modules of that system. So suppose we take example of say our institute. So our institute, suppose I want to automate our institute whole working. So we can think of different departments. So computer science department, this department, this department, this department, and we can develop the automation of this department in independent manner. So any system, any big system which you want to design, it is better to design it in an object-oriented manner, so that you can divide that system into independent tasks. And those independent tasks can be easily coded. And later on, you define interfaces between these independent modules, so that whenever they need to exchange information, they can exchange. Suppose all these departments need to talk to academics department. So all would be having interfaces to academic department. Their functionalities are different. They can be independently coded. But finally, they all have to talk to accounts department or academic department. So you need to define interfaces. Or there may be some point of time when computer science PhD student is guided by electronics supervisor also. So there has to be interface so that these two can talk. That's a virtue of object-oriented design. So when you think about computer networks, so you might have heard this term protocol stack or layered architecture. So when they were designing, and thinking about computer network, so what is computer network? It's a system software which has to run on every device. And this system software is a huge thing which involves so many things. So what they have thought about, let's divide this whole task into different independent subtasks. So they said that there is an application layer, then there is a transport layer, then there is a network layer, then there is a data link layer, and then physical layer. So they decided that, okay, these are the independent modules which we need to think of. Now, please be with me. Now, right now, this is not layered. I'm just saying that, okay, you have to develop some network application. That's a part of application layer. And then application layer protocol would be different. And we know about this FTP, HTTP, SMTP, all these protocols are there. Then what type of transport you want, whether you want connection oriented or connectionless transport, whether you want reliable, in order, everything correct type of transport, or whether you want unreliable, blast as fast as possible kind of transport. The network layer means you think about, okay, how to route data packet from one point to another, hop by hop, what is the best path right now, what is the best hop right now. So this is another independent task. And data link layer, you think about how your computer is connected. Data link layer and physical layer, you think about how your computer is actually connected to internet. It is by wireless or wired or something like that. So this is access network, how you access the network, and which physical mode you want to connect to the network, wirelessly, optical fiber way, or a copper way. So these are the different independent tasks. What network system software has done extra, it provides one restriction also, that application can talk to transport only. Means application can take services from transport layer, transport can take services from network layer, network can take services from data link layer, and data link layer can take services from physical layer. Means the communication interfaces between these modules is having some restriction, and that's why it appears as a layered architecture. Means application layer cannot contact directly to physical layer, so they have to contact to transport layer to network layer to data link layer, so on and so forth. What are the duties of the different layer, how this decision has been made, that which how many layers are going to be, that's a detailed discussion, we'll come back to that, don't worry. Fine. Now Abhigyan, just think over it. You connect to network or internet in how many ways? Wireless or wired way? Yes, Abhigyan.
Wireless.
And you haven't connected it to wired anytime? Your laptop?
Yes, many years ago. I mean, if you're saying to the like internet or the mod.
Means you connect your laptop to a wireless access point, and you can connect your laptop to using a data cable to a
Yes,
IO port. Okay?
yes,
So this is that Cat6 cable you use, no? The data cable. Fine. which this RJ45 type of jack when you connect it to the IO port. Yes or no?
Yes, sir.
And then wirelessly you can connect to the wireless router of your house. Okay.
Yes.
So when you do these things, do you change the application? No, this is the wireless application and this is a wired application. Do you do this? Huh?
No, sir.
Now you understand the beauty of layer design. You can change the physical layer without affecting the application. Means application is not dependent upon which physical layer you are using. You can use physical layer A, B, and C. You can use data link layer A, B, and C, and this is not going to affect the way you are using the computer. Are you getting my point, everybody? Abhigyan?
Yes, sir.
This is the beauty of abstraction, which object-oriented design provide. You can change one module and replace it with another module without affecting the overall design. That is known as abstraction. And this particular thing is provided by encapsulation, which we'll discuss on the next turn. Okay? Just a minute. क्लास में हूं मैं, बताओ जल्दी से. हाँ? अच्छा ठीक है, मैं अभी राइट नाउ क्लास में हूं, मैं बात कर लूंगा. ठीक है. Fine. So the abstraction is provided by encapsulation. So we'll stop here. If there are any questions or any queries, you can ask. Otherwise, I'm done with today's lecture. And on Friday, there would be lab. Fine. And first lab is very important. So you all are requested to attend that. Any questions from anybody?
Yes sir. Hello sir.
Yes, yes, बताओ.
हेलो सर, वो प्रोटोकॉल स्टैक क्या है सर? वो समझ में नहीं आया.
प्रोटोकॉल स्टैक डिफरेंट मॉड्यूल्स हैं. ठीक है. पूरे नेटवर्क का काम करने के लिए पूरे टास्क को इंडिपेंडेंट टास्क में डिवाइड किया गया. ठीक है, कि ये
ठीक है सर.
ड्यूटीज इंडिपेंडेंट है और वो मॉड्यूल बना दिए गए. फिर एक रिस्ट्रिक्शन डाल दिया गया, नहीं सब मॉड्यूल सबसे बात नहीं करेंगे. मॉड्यूल आपस में जब कैसे बात करेंगे वो रिस्ट्रिक्शन डाल दिया गया कि नहीं, एप्लीकेशन केवल ट्रांसपोर्ट वाले मॉड्यूल से बात करेगा, ट्रांसपोर्ट केवल नेटवर्क वाले से बात करेगा. अब ऐसे करके इसको अगर लाइन से लगाएंगे तो स्टैक नहीं बन जाएगा.
हाँ यस,
एप्लीकेशन हो जाएगा, फिर ट्रांसपोर्ट हो जाएगा, फिर नेटवर्क लेयर. इसी को कहते हैं प्रोटोकॉल स्टैक. और हर एक मॉड्यूल की अपनी अपनी प्रोटोकॉल है. So that's why it is known as protocol stack. ठीक है?
यस सर, आ गया सर. थैंक यू सर.
Anybody else? So if there are no more questions, then we can stop and we'll meet again on Monday. Thank you. You guys can leave. Thank you.
Thank you, sir.